So hello everyone, I'm Alex. I'm a CTO from Streaming Fast and dfuse, and I'm really happy to be with you guys today. With all of you guys that are gonna be hacking your way through some new blockchain development and projects. Today we want to present a bounty. I'll do that just at the end. And before that, I want to give you a high-level idea of what we're doing here at dfuse and what are the tools we're putting at your disposition. And it will give you a goal for the bounty. First, I guess a little bit of backstory from me. Okay, so I'm a father of 7 children, and I've started my journey in blockchain in 2013, where I founded a company to do Bitcoin payments. And then fast forward a few years, I ended up running a data science team at Intel, the large Intel chip maker, and run a data science team there, and always wanted to come back into blockchain and to build data products, which is what we've done here with dfuse and Streaming Fast for some of the most performant chains, and we always tried to make the best and simplest and slickest APIs. So okay, so today we're presenting Streaming Fast, and Streaming Fast is I'm going to share my screen here so that you guys have a good idea of what I'm going to present here. 3, 2, 1. So this is the Streaming Fast website here. And the goal of this is to be a streaming first solution. There's blockchains that are getting faster and faster, and streaming is becoming the best way to consume data, to be listening on the blockchain, to see what's coming. And this method is the most reliable stream that there is right now in the industry. Streaming Fast today is for Ethereum data, but if you ask us, we do have the same product for some other chains, namely EOS-IOs and chains and Wax. And we also have that for Solana, which is a high throughput chain. So if you're interested in those things, come and talk to us. In the meantime, this is going to be for Ethereum, and I guess that's the scope of this bounty and this hackathon. So we have a few good partners that are using that technology to build great things, and we thank them because they've been really useful in their feedback and in us, building a better solution together. And what we've received as feedback, and really happy to put that here, is that, a lot of developers are querying blockchain nodes. They want to know what's their balance. They want to know, what is the current reserve in this Uniswap pool or something like that. And oftentimes they need to write a lot of code to make that reliable. And so some of our customers, they came to us and said, look, when we integrate Streaming Fast, when we integrate this technology, we're actually able to remove 90% of their code. They were able to shrink down their code because the service does the hard part of giving you reliability, of not needing to running a node yourself, of fixing the issues when you're querying some load balanced nodes, right? Where you have, let's say, a service provider that has 1,000 nodes and you're querying one and the other, but they're not at the same height because they didn't receive the information at the same time. So you need to, on your side, reconcile, I had 1 million here, I had 1.5 million here. Oh, what's the truth? Then you need to retry, and it adds latency. So all this thing is extremely simplified because there's one reference stream. You get to the stream and you will reliably and fastly get always the latest information, the latest state of the blockchain. So really listening on the chain. Now, with that solution, you can get a lot cheaper. So, we've seen projects, what they're doing, they're listening on the chain for any transfers, for example. If there's a transfer coming to my address or a transfer going to Uniswap or something like that, then I want to make an action. I want to know the new balance. What is my new balance? There was a transfer for 1 million, but what was my previous balance? And so they go out and do 1, 2, 5, 100 get balance or get reserves, or so balance of to understand the new state of the blockchain and then update their widgets and then change your balance after a certain transfer. Well, all of that information is contained in the stream. So there's no need for the most part, for most of the common things, there's no need to go and hit the servers or nodes again. You can extract the new balances, the new reserves directly from the stream. So you have much simplified user experience and developer experience. There's a transfer in there. You see that the old balance was that amount and the new balance is that amount. You don't need to go and get the balances. The reserve has been updated. Here are the new values, the old value and the new value for both reserves. I'm thinking Uniswap, simple Uniswap trades. So that's very interesting. It simplifies it. So it means you can ship something faster and it's going to be reliable and sustain going to production. So that's cool. So how we do that is by providing what we call a cursor. And I'm going to show you here the way this works. So this is a sample execution, right? You get a key and we'll get into the usage of the key. And then you punch in a command, which looks like this. This is a small binary that we provide here for Windows, Mac, Linux for you to get started extremely fast. You download that, set a key, and then you can get that through your email by going to the website here. If you want a key, you go here, start streaming, you'll get a key, and then you can start streaming, okay? And then you can filter. So this is simple language to allow you to get only the transactions you're interested in. But mind you, this will match internal transactions. On Ethereum, you send a transaction, let's say it says withdraw. Well, that might call another contract with a transfer. So there's a call stack of contracts. Well, this will match the internal calls. So if you're saying watch Uniswap, like this is the case here, any calls, any transaction that touches the Uniswap contract, the Uniswap router there, it will match. And will return the full transaction so you can inspect who called from which direction. And right, you have a lot of information, which we'll get into in a few moments. Then you'll give it the start block and end block. So that solution is also historical. It means that you can go in the past and for very cheaply, you could actually stream the whole blockchain history if you put 0 here and then you put no value there. It means you'd start from block 0 and stream forever if you don't specify an end block. So it literally allows you to stream the data of all the chain, all the history, right, with great depth and all the calls to Uniswap ever. And then also, if you don't specify an end block, to continue streaming on and listening to the chain, right? You're going to get the new transaction in blocks as they come in. And so the special sauce we're talking about is the cursor. It is also possible not to start with a start block, but to start where you left off. This is where we have the cursor here. Each block that you receive, you can observe here a sample output. It's quite large sometimes when there's a lot of transaction, a lot of things happening. But for each of those blocks that you're going to receive, you have block information and then transaction and all that. We'll look into that after. But you get those important information here. That means this is a new block, just been mined. And this here is a cursor. It's a little piece of information that you can provide back if you ever get disconnected. And in which case, we will always continue the stream exactly where it left off. Now you might say, yeah, that's easy. Anyone can do that. The thing is, there are really tricky edges when you're in a reorg. Like, let's assume you're in a reorganization. You have a block, another block, and then a third one. But this is to be reorged because there's a block of the same height that is arriving and another one that is higher. Okay, so you have the longest chain was just changed. But last thing you had information about is this block here. You will need to have it undone. This is not true anymore. The new block is a new one. So you need to have an undo signal. That's where you'll have the step undo. And then the cursor telling you, oh, you're from there going to there. And you will get, so again, when you get the step undo, you will get the whole block information again. So that means You don't need to keep state on your side. Oh, what do I need to undo if I ever get a reorganization? You'll just get the information back. You can figure out what you wanted to do there and undo the operation. Okay? And the cursor will always give you the exact point you left off. So even if it's the middle of 5 undos, removals of blocks, we will continue in the middle of the undo and continue to give you an absolutely linear stream forever. And okay, I guess that makes one point. I think it's already interesting. That is the fact that it's reliable, something that native nodes cannot do, because this is a stream of a view of the network. So a single node is only views one aspect of the network, while the stream sees all of the blocks and forks of the network and can therefore make make your way out of a reorganization with no problem. Okay, so connecting to a WebSocket node can never give you that reliability. Now one thing that we're really proud of is that this is actually the fastest solution out there. The fastest, faster than you pulling Infura or Alchemy or whatever provider to get blocks, faster than getting filtered logs on Ethereum, where you're filtering for certain transaction. Here you're using a language, right? The 2 is in a certain list or with equal signs. We can look into the docs for that. So this will come in not only a few milliseconds, but 2 to 3 full seconds before. So if you guys are building trading bots, if you're building things that you want to be racing against other, and where fast and where speed is important, you definitely want to use that stream instead of polling other nodes, because if you can have an edge 2 to 3 seconds, you can take better decision for your trades. So this is the perfect stream of what's currently happening. And how do we do that? I think it's quite simple, is the fact that this infrastructure, it being not one node, we have a few nodes. Let's say we have 3 nodes for simplicity. And the moment one of these nodes see a new mined block, the miners just received a block, and this one hits it first, poof, it's going to push it out to you immediately. It's a push mechanism. And the next one will receive it, then it's going to be deduplicated. It's not going to send it the second time, and the third time also. So the first one to get the mined block will send it out to you, meaning they are actually racing all the nodes dispersed in the universe. Well, of course, not everywhere in the universe, but they will actually race to push data to you. Whereas when you're using systems that have 1,000 load balanced nodes, well, there's a lot of propagation delay. You have a miner sending a block, and then you have 1,000. So they're not all connected to the miner. So you have a first layer, and then the second layer, and then they're executed, propagated, executed, until they hit one of these nodes that you're connected to. And then from that node, you can stream data using the WebSocket, native WebSockets of the nodes. But then you're very late because of the way the data is propagated on these nodes in a large pool of load balance nodes. Okay, so this thing is faster by design, and it is faster empirically too, by 2 or 3 seconds. Okay, now I think I told you guys about that. You can stream data from Genesis. So some people are maintaining archive nodes just because they want to be able to access either some trace information in the past, or some block, having a larger pool of full state in the past. Well, this stream will provide that to you, and will provide the data you need. So you don't have the data. And most people are interested in the data rather than having the bulky node and then trying to fit it on a server there, because you're interested in the data. So that's the solution that it offers that. And we'll see that also, maybe it's a little deep there, but the stream, let me dig a little bit in the richness of the stream, because that's the next point here. The data we provide, that is provided by this system, is much more rich than what you get from getting a transaction from the node. And in some situations, like especially at this time with a lot of DeFi, having more data, having data faster gives you an edge on competition. Therefore, you can grasp opportunities, arbitrage opportunities or other opportunities better than other people. And so if you have more data, you can be more precise into what you're going to race and get there faster at a better gas price, making you win like more trades. So in there, we do have the full stack of transaction. Like we have a service that is built on that. It's called ETHQ. This is a block explorer, quite as simple. And you'll see here the plus 15. You see the call graph, right? There's a Uniswap router call, which is going to call permit here on another contract. And this is going to go and get a method to get a static call, meaning, just get me some information. You have all these calls here. You have the gas being used at each level. And in there, let's see. This is a visualization. Let's do this one here with the plus 8 of what you see in the stream, right? You should have visualized what's in the stream. And this one here has a bunch of things. It has input values. This is the data that was inputted. And then there's all the balance changes. There was an ETH transfer. In some situations, actually, internal ETH transfers like this one, it's transferring ETH. It is not visible at all when you're querying a get or a parity node. It's not visible because what you see is the topmost call. And the topmost call has a value of 0. It didn't transfer Ether. But because you're swapping ETH for tokens, well, there's an actual ETH transfer underneath, but there's no way for you to know. And in this case, what we're going to give you is not only there was an ETH transfer, but we'll give you the previous balance and the new balance. And if I want to show you that in the stream there, because you'll be interested in seeing that. This is the data that is sent to you. Balance changes mean internal ETH transfer or external, but you have the address, the old value in hexadecimals, and the new value. And you also have the reason. Was it for a transfer? Was it because you bought some gas? Was it because you had to refund some gas in some situation or transaction fees? You will know the value of ETH you had before all these operations and after. So to keep, an exact balance right now without you needing to go to the chain and ask for your latest balance. And you'll have that very granularly down at the call level, right? Not only transaction, the transaction is the whole thing here, but each call you'll have the exact value. So if you're doing any accounting, you definitely want to have that level of precision so that your things balance out, right? And want to know what was paid in everything. And so if you're building tax software, by all means, come to that stream and get all the data you need so that you can build better accounting and more precise accounting software. And now you have here log events for the wrapped Ether deposit. You have all the logs. These are standard logs that you'll get, that you're able also to get from the nodes, but you can search through them and you'll have them associated with the right call, associated with the balance, and associated also with the state changes. You might have seen that from Etherscan. They have a little tab there where there's resurface the state. Well, in here you have within the block transactions and their calls and their state changes for you to consume programmatically. And one very interesting thing that can be done with that is that you can obtain this information, which arrives for you already decoded. What does that mean? This gives you your new balances in terms of ERC20 balance changes. So if there's a transfer in this, so in this one, there was a transfer event, right? A log event that's sent from and to a given amount. That's a log that is interpreted from the these things here, which are basically log events, okay? That's an ERC20 transfer. It arrives here decoded for you. And you get the balances for each of the, the from and the to. You would need to go and query the chain again, balance of for that address to know the previous or the new balance. And then you have risks of inconsistency depending which node you're querying. Or if it so happens that a new block has arrived and the balance has changed again. Now you have guarantee that this is the balance at that point in time, and you can update either your UIs or widgets or update your trading engine so that you know where you're going, or write that in a CSV file for tax purposes. Or you can take decision, for example, for our bounty, to use that because they have traded enough of a certain, if they had enough of a certain token at some point in time, then you want to keep that address because this is an address that, that abides by your rules. If your rules for airdropping mean like you need to have had at least 5,000 of such token, well, the moment you see a new balance above 5,000 for that address, you keep the address, right? Put that somewhere. This is your airdrop result. So it'd be very difficult to have certainty if someone has touched 500 because you wouldn't have it. It would be just summed up at a block level. Here you have it at the transaction level. You know if they have touched 5,000 more precisely. So as you can see here, you don't need to go get balance. And there's a lot of information that can be extracted from the state changes that are here. These are the storage changes, the actual value of the blockchain. And these can be interpreted to extract all the reserve changes from Uniswap. If you need help with that, just come to us. We have a little bit of snippet of code to help you, understand this address has a value of this and that. Well, that might just be the reserve 0 and reserve 1 for Uniswap, for those who studied that a little bit, the reserve of the pool. So like that amount of money here, that amount of money there, and you can, using those two values, know the price that is within the Uniswap pool there. So you can take decisions based on what's the current price. The price is conveyed through that information. Okay, so right, so we have general info, the value being transferred here. And as I said, you have internal value transfers, which is not available when you're querying blocks or nodes on standard nodes or transaction on standard nodes. This is just not available. Better data, better systems. Okay. Now, a bunch of things you could be doing with that is, as I said, you could take the stream, put that in your own database reliably, and then you can take decisions on your database. But you can also, keep your users' tokens balanced up to date, like I said, and then always have it fresh with much simplicity. Or what we imagine also, you can use that to feed your dashboard. So you have someone connected to your dashboard, and you have a stream of updates that updates the dashboard in real time with the latest data in an extremely simple way. Just one stream, no funky call. Just interpret the data in there and fill your cells. So you have an extremely fast dashboard, 3 seconds earlier than your competition, that is. So that might give you an edge again and a good user experience. Of course, feeding your trading engine, I think it's a no-brainer. If you need it, if you're writing a trading engine of any sort, you definitely want it to be hooked to that stream and not other things. Well, otherwise you'll lose to those who are using it. and then also, this is useful to giving user feedback when things get settled on the chain, right? If you have a transaction you're watching, then you can use that solution. But let me go to also the public APIs of Ethereum. There's one thing I wanted to show you there. There's a lifecycle endpoint, and this is on diffuse side of things. The lifecycle here. There's another endpoint that you can use for that purpose, for keeping track of transactions that are in the mempool. Now, I don't want to take too much time on that. I have a few minutes left, and I want to go to the bounty. But this is another feature that is not yet in Streaming Fast. We're porting things for Ethereum, at least, from dfuse to Streaming Fast. So if you're interested in this allows you to keep track of what's happening on the mempool before it even reaches a block. And the unique feature of that is, first of all, it's an extremely simple endpoint. You connect once, and then you will get the complete states, and it's going to be reliable. You can reconnect. You will get back that state. And so you'll see if the transaction is pending. And you can search by transaction by from and to, or by a transaction hash. So you can be watching one exact transaction or a bunch of transactions that are matching, either ERC20 transfers in and out, or, things touching a certain contract. And then you'll see, oh, it's pending. And then you have that little loop here, which seems to be looking like nothing. But this little loop will actually execute the transaction speculatively and provide you with what would happen if that transaction was executed and mined right now. So sometimes, like the previous function we saw here, you will only see a swap at the top level transaction. All of this does not exist before it's executed. But all of a sudden, if you listen to that stream, you will get all of that information speculatively, which might tell you the intent of the transaction, because you're only seeing that transaction, that call, when you see on the mempool. Only the top level transaction is seen before it's executed. So you can get all that information, know which potential log events is going to be executed, it's going to be produced, how many value, what are the Uniswap pairs that are going to be touched in here, what are the what's the opportunity that's being captured, and then you can inform that on your trading engine, and if you're going to do trading, and then race the right transaction, right? Because some people are trying to be there in the mempool and they don't know which transaction is going to affect their opportunity. If you're smart, you're going to go get speculative execution, and you don't race against those who are not taking your opportunity. So therefore, you can have a lower gas price and be part of the game better. Okay, so that's for traders, but we wanted the bounty to be simpler. Okay, we wanted the bounty to allow you to just jump in there very fast. So give me half a second. I'm going to get the bounty out again from here. I want to list you the exact statement for the bounty. So here, do you see my screen again? I hope you do. This is the bounty we're after for us. So that amount of USD there for building an airdrop honoring system. So a lot of projects are going to airdrop, like they're going to try to honor some like Uniswap, right? They have airdrop to people who have used their product. A lot of people do that for different reasons. And if you select a project that you know and like, and they haven't airdropped yet, well, we want you to create a stream, get from the stream an algorithm that would make sense for them to honor. So something that would make sense, like if you have used this part of the chain, right? If you have used this or that contract in this or that way, transferring or a certain number of value, then you can take that stream that we're sending here and do analysis on it and extract the addresses, put them in a small list, and then that would be the list you could give to the project for them to honor, right? Then you can go back to the beginning of their contract, start streaming from that block up until the tip of the chain, and then you have a live airdrop capturing system. I think it's simple enough for you to get started. If you're new to the system, if you're new to the structure, now the structure of Ethereum data, you'll see that it's pretty opaque. This is an address, right? This is a value. This is actually an integer value. So you need to understand a bit of all these things for you to do that, right? For you to build a good airdrop capturing system. But that will get you to the next level, and I think it's actually useful, and it'll get you a taste of what's in there. Now, I want to, these are our backers, and Now, I want to tell you something important. I'm going to stop sharing my screen because I don't need it for now, for that. What you just saw in Streaming Fast is actually very interesting because it's a solution that is used by real people right now, paid for. It has market validation, and it's the best solution for streaming on the market right now. Best solution for streaming, hands down, and that is across chains, because this is a small layer that is needed above the different chains to make it reliable, to bring more data than what the chains provide. And this is available on several chains right now, with us working on more chains. And this is only valuable, I mean, it's maximally viable and valuable if it's decentralized. So what we're going to do next is take Streaming Fast and turn that into a validator system where people extract data from chains, make it available through this method, race together to give you better service, and incentivize them through token economics to run that service and be paid by users that need to consume it. So what today you will be connecting to our servers to fetch, we'll give you the best speed we can. We have, professional services, but it's only as distributed and decentralized if it actually doesn't live only on our servers. And people are empowered to run it by themselves, share the data, but also validate the data, because the data provided here is not all covered by the underlying chain. There's more, right? There's more data. So we want people to give you better sense of security of that data of the underlying chain. For that, we need mechanism to give you economic, cryptographic certainty that the data you're being transferred is correct, and there are economic security baked in. So when you get the data, you can verify signature of the whole payload and see this was, produced by someone who had $1 million at risk. So I can trust it at least up to that level. And then you can do that with many of the validators eventually. This network is not live yet. You guys are getting a sneak peek into that early. If you're interested in what that could become, then let us know, because we're interested in partnering with those people who might have, either validator skills to run these systems, or they have a desire to run, applications that rely on decentralized data like that. They need that sort of richness of data. They need that speed, but they also need it to be decentralized. I'm thinking anyone building bridges to different chains, because this is absolutely the sort of data layer that is required by any bridge. Like, on a bridge, you're listening to one chain, listening to another chain, and then writing on the other chain, right? You're bridging. So you need to be listening. You want a fast bridge. You want the fastest streaming solution. And so if you're building bridges, a lot of layer 2s are looking into that. If you're building a layer 2, you're also listening on another chain. And some of them, most of them, I would say, need rich data. They will need data that is in part of the calls. For example, these, an internal call, they will go outside, do some off-chain computation, then bring it back to the chain. They need internal data, which is not available when you just, get blocks from a standard node. So that is information is needed. And of course, a layer 2 needs to be decentralized. Therefore, relying on that decentralized layer of data is paramount. So if you guys are working on things like that and you're interested in that decentralized aspect of streaming fast, by all means, let us know. Now, let me see if there's any questions that cropped up in the stream there, because I'd like to answer if there's any specifics. And also, you guys here, who am I with? Pay in. If there's any questions you wanted to bring to me, now would be the time. In the meantime, so if you have questions here, that's practical. Decentralization, yes, Wild Kid, thank you. And yes, speed is very is of essence. And you know what? In chains, like if you're on Ethereum, okay, 15-second blocks might be okay. So you have time, you get information, you turn around and you get blocks, or you get balances and you update the reserves and whatever. But when you're on BSC or other chains that are faster or Matic or whatever, like sometimes you don't even have the time to turn around and query the node, because the state will already have changed. So getting on faster chains, getting consistent information from the chain by doing polling just becomes impossible. So as we're seeing faster chains arrive, adopting that streaming model and the technology that goes with it, and jumping in, let's say the decentralized layer that will provide that for all chains, I think can be very edgy and interesting, especially because I think that's the way, perhaps the only way, or perhaps the most used way we're going to see in the future, because people are not going to poll forever. I'm telling you that. Sometimes it just becomes impossible. So
hi, can everybody hear me clearly?
Yeah, go ahead.
Yeah, so 大家好，我是 dfuse 和 streaming fast 的中国市场负责人，我叫 Anthony。然后我帮助大家，如果有什么关于刚才 Alex 讲的关于 streaming fast 的服务，还有整体的架构、数据，或者说关于去中心化这一方面有什么问题，大家可以在直播群还有这个哔哩哔哩上给我们留言问问题，我会帮助大家翻译一下，如果需要的。So Alex, I do have a question that I'm seeing.
Go ahead.
Here first, how does dfuse handle reverted blocks?
Very good question. So dfuse implements dfuse streaming fast. That's part of the core architecture, and it supports multiple chains with their different algorithm for reaching the canonical chain. On Ethereum, we have the most weighted chain. On some other chain, like Bitcoin, it is the longest chain. So that algorithm is implemented at the diffuse layer. And so when we have information of new blocks, we will actually compute what is the current longest chain, what is the canonical chain according to the algorithm from the chain we're in. And in that case, we will know that according to the consensus, right? That's the consensus algorithm. We should switch chain, right? We should reorg. And in that case, we will take, let's say we had 1, 2, 3, 4 blocks, and the fork happens here. So we need to change 3 or 4 blocks here. We will undo them in order. We're going to send you the block again with a note saying step undo. We're going to remove that one, then the second one, then the third one, and then we're going to start applying this one as a new, and then that's how you will be able to repair things, right? To correct course on the data. And most systems, what they will do is they will say, okay, block 5, 6, 7, 8, and they'll say, oh, undo 5 or 4 or something like that. They'll just give you the number. So you need to have on your back end, oh, what did I do for 4, 5, 6? What did I do? I need to undo these things. Whereas we're going to send you the data, the whole data payload. So you can just run the same, analysis function on the block to take the reverse decision. And because on each of those blocks, you have the previous state and the next state. And you have the same for balances, previous balance and next balance. You have all the information available to completely undo what you did. There's no missing data. And so you can apply in reverse. Just take your analysis. Oh, I had a balance. I'm going to flip the 2 values and I'm going to apply the previous. Do that in reverse order. And then you can continue on with a guaranteed stream of linearity and much, much simplified architecture. Now there's that, but there's also getting to what we'll call finality, irreversibility, or probabilistic finality. There's a level at which we'll say it is irreversible. And what we'll do there is you'll have the new ones, the new blocks, and we will send you those blocks again with the same payload if you ask so, right? Because you can ask only for the new blocks or only for the irreversible blocks or finalized blocks. And in that case, we'll send you just the one you want. But we can send you both in the same stream. So you get new blocks, and then you have the irreversible blocks that arrive with the note step irreversible. And then you can take action when it's finalized, but again, with the whole information available, right? So we'll have the 2, they'll go that in the stream. I think it's the most complete and makes it the simplest for the consumer. Does that answer the question? Hope this answers the question.
Oh, thank you. Thank you.
我看大家有问说有没有文档之类的。
Yeah, another question is, for the decentralization and the mechanism of it, is there a document available?
So you keep your eyes open because this thing is going to come out soon. We have some light paper in circulation. It's not fully, not everything is fully decided there. But we're very, what we did is we worked on for many years, 3 years more now, on such a system, and we've iterated on the business model, and we figure out a good business model where people actually want to pay and value the service at a good rate, right? This service. And now we're decentralizing that. Whereas, we've seen other products say, okay, we're going to figure out the business model after decentralization, or the decentralization is going to be the experiment on the business model. I'm actually really happy that we have a good business model, and decentralizing it will make a lot of sense, and it's been tested and people have paid for it. So yeah, to answer the question, I don't have the doc for you to send today, but keep your eyes open because it's going to come out soon. And if you're interested, contact us. This way, if there's a partnership we can be doing, that might be interesting for both of us, like for all parties involved. Does that make sense? I see a question also about GitHub. I'm going to put on the GitHub, if you click on Start Streaming Now, it brings you to the GitHub page. And right now you have the binary to get you started extremely fast. It's going to give you JSON. So you can run that right now. It's going to be easy for you to jump in. And I'm going to also, so this is a gRPC service. So if you have your coding skills, I'm going to go add in that repo the links to the gRPC service name and the data model you need to load. And you can use that in any languages that supports, protobuf and gRPC. It's like 15 popular languages there. So I'm going to add that in just a few moments. Okay, so you can start doing programmatic access. And you can look also at the source code of that sample SF file. It's just a simple main. If you want to get started in Go, you can jump in right away. It's already built there, and you can program around it. Hopefully that's helpful.
Yeah, I see the question, Alex. 我看到大家有问，要买币锁仓 staking. So are we planning to have when decentralizing streaming fast? Are we planning to have a staking mechanism? Are people buying tokens, locking them in?
All that token, all that decentralized economy story will come about. So stay tuned and contact us if you're interested more seriously. But that will come out. It's not out yet.
我看大家现在没有其他问题，大家有问题可以接着问。那我现在由 DoorHacks 这边 Hacklink 的工程师先演示一下我们如何去提交这个 bounty 在 GitHub 上面。然后麻烦 Anthony 跟Alex 说一下，我们先由工程师演示一下怎么提交 bounty。然后大家有问题可以接着在弹幕里面问。
So Alex, that's the questions for now. And we're going to move on with DoorHacks engineer explaining how people could claim the bounty.
Perfect.
And people will ask questions during this. If we have more questions.
Thank you for having me. It's been a pleasure.
Stay here, and we're going to run a little longer. Yeah.
让 Alex 结束一下屏幕共享，那个振川这边要屏幕共享。
好的，可以听得到吗？
可以听到，
好的，那我这边就简单说一下怎么在平台上就参与我们的 bounty。首先我们平台的 bounty 实际上它做事情比较简单，就是把 GitHub 上的 issue 和我们链上负责激励的这个合约联系起来。所以对于开发者来说，第一件事是先在我们平台上找到你想参与的 bounty， 然后通过这里参与 bounty 呢，把你的 GitHub 账号和你的区块链的账号绑定在一起。那么这一步就是我解绑了一下我自己的账号，然后走一下这个流程。对，然后你可以通过 MetaMask 或者什么联系到，我这边看不到了，不好意思。像刚刚的话，我就是完成了我 GitHub 账户还有区块链上账户的一个输入，然后我直接在这里确认。确认完成以后呢，平台就已经将你的这个区块链的链上的地址和你的 GitHub 账号有了一个绑定。那么接下来你要做的事情其实很简单，就是在 GitHub 上去完成这个 issue 上给你提的一些目标。这个对于开发者来说，我觉得这个过程应该并不陌生。那么你要做的事情呢，就是把代码 fork 过来，然后根据 这个 issue 里的内容进行你的开发。然后我可以简单的演示一下这个过程。当开发完成以后呢，你只需要提一个 PR 到这个 issue 里，然后你们可以在这个 issue 的评论区与这个项目方进行讨论或进行更改，直到项目方同意你这个 PR， 认为你这个 PR 已经达到了 issue 的要求，就可以将它 merge 进来。当 merge 进来以后，我们的平台上的 Bounty 会自动感应到这件事情，并且在智能合约里进行一个提交。这个项目方所设定的这个金额就会自动的进入到开发者当前绑定的账户里。所以说，实际上大部分的操作都是在我们的这个平台之外完成，在 GitHub 上完成的。就开发的流程就和平时的一个开发的感觉差不多。我需要在这里把这个流程走完吗？我不会真的提个 PR， 然后我也不会真的把这个东西上传上去。那么其实我要说的就这些了。我这边好像因为网络问题，这个并不是很好，我看一下啊。我不会把这个真的提进去的，我只是走这样的流程。可以参考我们一些已有的 Bounty， 可以看到就是提交以后的一些效果，看看。这是一些已经结束的。
可以看 BIC 的那个 BN 的那一场已经结束了。
我看一下，我不知道是哪一个呀
？BN 的那个。
这个吗？
应该是，不是这个。BN
应该差不太多。
3000 USDT 的一个3000 USDT。
好，我这边网不是特别好。
2000的这个成为 BN 的
就是这个是吗？
对。
好的。我这边假装走一下这个流程吧，我不会污染这个项目的。好像网络状况我这边有一点问题。点进来是吗？对，就是当在 GitHub 上有人提了 PR 并且 merge 完以后，直接在这边就会有相应的显示，项目方就可以在这里直接把这个链上的这个奖金，这个直接打到开发者对应的这个开发者的账户上，然后在这里也可以看到他在链上的一些状态，然后我们就不详细说明了。然后像对于开发者来说，我刚才这边同步演示的就是当你的代码你认为已经达到了这个 issue 的目标的时候，你就可以提个 PR。这是哪个呀？对，直接提个这样 PR， 然后这个按钮按下去，你就等于已经把你的一个解决方案提供上去了。那我这里肯定是就不继续操作了，不把我这个脏代码提上去了。我要展示的大概就是这些。你看是否已经完整 ，Penny？
可以了。谢谢郑川。
好的，那我这边结束共享。
大家有问题还可以继续问Alex。你这边有看到有其他的问题吗？
我这边看我就看 BBD 和群里，目前没有其他的问题。
那问一下 Alex 有其他的补充吗？
Alex, is there something more you want to add?
Except thank you for being there, and let's have fun together. I guess that's what there is now. Thank you for trying that out.
好，那谢谢 Alex 和 Asni 来 DoorHacks 做的分享。如果想认领这个 Bounty 的话，大家可以进群，有问题的话在微信群里互动，或者直接在 GitHub 上提交，然后在 GitHub 上和dfuse 的团队直接去沟通就可以了。如果你的代码被 dfuse 团队 merge 的话，那么这450 USDT 的奖金会自动进入你的合约账户。然后以后我们那个 dfuse 也会发布更多的 Bounty， 所以欢迎大家关注。我们今天就到这里，感谢大家。